Hi everyone, welcome back to DS3 Podcasts. My name is Cindy and I am a content writer here at DS3, and today with me I have a very special guest, Professor Kyle Shannon.
Thanks for having me.
Yes, how are you doing today?
Not too bad. How about you?
I'm doing pretty good too. My first question was just for viewers. Since a lot of them are undergraduates, I was wondering if you could walk me a little bit through your journey through data science, like how you got started and what you do now as a professor.
I started in data science in 2013 or so. So it was like I fell into it because I had gotten a job working in DoD, like defense consulting. They just hired under a general STEM type thing. And I wound up falling into the position of data scientist. Yeah, didn't really know too much about it. And back then, nobody else did. And it's arguable that people today even know much about it. Yeah. But I sort of had to translate just the general background knowledge that I had in my STEM undergraduate degree, I suppose, and what little work experience I had so far before then, which is working for a small neuroscience startup company called Backup Brains. And so a lot of late nights at coffee shops, getting better at programming, going through like Bishop's pattern recognition textbook, just trying to kind of get those basic skills that one should probably have, all while developing more of the domain expertise. Specifically, a lot of the areas I worked in were like hospital kind of optimization projects, like how do hospitals optimize ordering supplies and stocking all the rooms and wards with those supplies. At the Balboa Navy Medical Center Hospital in San Diego, and that kind of work. And it was a lot of ill-defined stuff. A lot of data science that time too was taking methodologies, I think, that were built from like Six Sigma and stuff like that, kind of like process improvement and optimization. So it was sort of like a great way to get a large hands-on stratified outlook onto all the different areas in data science and trying to, get better with databases, get better with things like, distributed computing, Spark, and that kind of stuff. And so it was I guess maybe a little bit lucky back then because I didn't have to interview for an actual data science position.
Yes.
But I also didn't really have too much hands-on guidance, and there was no AI back then to help. So so there was a lot of like kind of learning on the go and defining your own direction. But I kind of prefer that, like being in that kind of environment. So it was good for me because I got to kind of define those things. And I think that data science has moved in an interesting direction since then, one that I certainly wouldn't have predicted or expected. But I guess you never know where things are going to kind of take off for you. And so that's why it's always good to just keep an open mind and, talk to people. And I think so. That's probably a good overview of how I got into data science.
That's really interesting. So would you say that you kind of started with more like a healthcare background and eventually got more like into coding and like computational stuff, or was your like undergrad in like more computer science, and that was something that you discovered later on?
No, my undergrad was definitely more in neuroscience and those kind of areas. It was a cognitive neuroscience undergraduate, so I really didn't have as great of a handle on computing stuff. I mean, I could write a little bit of code, and I worked with MATLAB, and at the time, what was 18 was Math 20F, which is not a fun class. But I mean, those are, you kind of graduate with a little bit of those skills, but nothing like what I think students are expected to have today. And it's much more focused now. And so, but when I was on the job and learn, I mean, you got to think about it too. If you're a student and you're going to school learning things, you're taking lots of different classes, you're putting a couple hours here and there into stuff. But at work, you're doing 8 to 10 hours a day, every single day. Over a couple years, all of a sudden that's several thousand hours of doing something. And so you get much better at it, and it's much more directed and focused. And the feedback loops for what it is that you're trying to learn and get good at, you're able to tighten those and couple them. As long as you have good people to learn from, or you yourself are able to go and find information and then learn from it, which I think is one of the most important skills you can get coming out of the university, to be able to teach yourself stuff. So that's really important in data science.
Do you think that there were any like specific stories for it? Because it seems like your path wasn't a very linear, since like at the time data science wasn't like no one really knew what it was.
Mm-hmm.
So I think as a field, it encompassed like a lot of different things. Do you think that there's any specific, I guess, like anecdotes that you have that you would say like were defining in your career trajectory?
Yeah, I mean, so like when data science first started, I mean, these were probably 2014 when Twitter was still around. Well, as it was when Twitter was still built with Ruby on Rails, I think. There's always those things like anybody who's wants to do machine learning isn't qualified to do machine learning. Those kind of things. Like, I think it's true that the idea of data science was very sexy because it was so ill-defined. It was kind of mysterious. The nuts and bolts of data science are less so in terms of needing to just to sit down and get lots of work done. But I think one of the most important things, I don't know if this answers your question or not, so if it doesn't, just stop me.
No.
But it's the domain part of it is the most difficult part, way more than any math you can learn or any program you can learn, because programming, math, the technical skills of data science or machine learning or database engineering, any of that kind of stuff that you can do under the realm of data science, is mostly a fight with yourself and the tools, and maybe your colleagues who might not be as good at using them, who mess things up, or maybe you don't know how to do something that's advanced. And you can learn those things and get through them, or find people. I mean, you can pay somebody who has skills. But one of the most important and difficult things is working with people, and specifically people who maybe they know a little about technology, or maybe they have some inkling into how data science works, and trying to really get them on board with what it is that you're doing, and making them see you as an essential partner in the project that you're doing, and then also getting the skills and sort of knowledge that they have in their head into yours. If you're going to work on a hospital ordering system and you're trying to optimize how many, if you go to some department in the hospital like med-surg or something, and you're saying, okay, how many supplies do you need stocked, and when do you need to reorder them so that the lead time isn't so long that you can't get them and that you run out. And so a lot of that is working with nurses and doctors and hospital administrators and managers to determine what the current burn rate of stuff is, and how you're going to define the problem is, you're going to measure some sort of outcome. Maybe that's with how much you've saved. And even bandages have an expiration date. And so I remember there's this one person who, there's like this box of 2,000 Band-Aids or whatever in the department storeroom, and I was looking through them. I was like, oh, you guys use on average like 4 bandages a month or something, some small amount. So this is going to go. And just like fighting with the nurse, like, no, take my bandages, these are mine. And so, you're trying to like you want them to know that this is, it's good to have that stuff, but we're also having to get rid of it and throw it away if it's not getting used. And so it's a tight line. And this is really in traditional data science projects. And what I mean by traditional, I mean like we're going to go in there and solve a problem, not like a machine learning algorithm maybe, and that's it. But like you're going to do an end-to-end thing where you're going to take some sort of problem and then find a solution for it that includes coupling the domain with the technical skills that you have. And you're going to run into a lot of people, a lot of different opinions, a lot of different experiences. And you can't just say, well, you don't get those bandages because you only use 4 on average, and that's all we're going to order, or that's all we're going to stock. So you have to kind of like balance that stuff. And you only get to have an authority on those type of issues by having some of the domain knowledge and working with them and making them an essential partner. A lot of the knowledge of building a good data science product gets lost in the technical or the scientific or the statistical, and really most of it lives in the domain, and understanding and working with people and trying to get people to understand what it is that you're doing. And that's really hard to do because people who are typically technical aren't as they have a hard time kind of coming to terms with what it is they're trying to do, and to get people involved. You're sort of like I used to say, like the data scientists are like the social butterfly of companies, where you really have to be talking to a lot of people. You've got to be the person that connects the technical stuff, the highly technical stuff, to the end users or the users, whether internal or external facing of a company, and the data owners. And you're trying to get a lot of people on board to help you solve a problem. and you can't solve it without any of their inputs or with some of the information that they have. And so it's really hard to do that if you don't have a good handle on how the domain works, a good understanding of it. You don't know what drives these people, what causes them to make the decisions that they make, or you don't speak the lingo or the verbiage that they speak. It creates a lot of conflict.
I see.
And so it's really, like, having a domain is really important, and you just don't have your technical skills and you're good to go. You have to kind of start to specialize at least a little bit into some area. Like I wouldn't, it'd be hard for me to go into, an economic firm.
Finance.
Yeah, and be like, okay, we're going to go ahead and about face the U.S. economy and make inflation go away with my data science project. I have no idea how that crap even works. But it's flip side just for the hospital. Like, you're going to go in there and try and talk about these things, but you don't know any of the technical terms or any of the domain terms, and it's really hard to do that. So a lot of the learning that goes on for a data scientist in their primary years of working at a company is certainly learning how to write production quality code and some more of the technical tooling, but it's also trying to understand how you actually solve problems in a business and deploy those problems and measure their success and get people on board and all those factors and the politics that go into that. You become kind of part of learning. That is really different than going to class and trying to pass a test.
Yeah, that's so interesting, especially because I think like the curriculum today is definitely, it's very like bottom up. Like the focus is definitely on technical skills, whether that be like different coding languages. I have actually two-part question in response to that answer, which is really interesting. I guess one is like, I think especially with AI happening, I've actually like heard this from a lot of peers where people do think that like because of this, maybe the role of what it means to be a data scientist will shift, which kind of, I guess, goes in line with like, I think having the technical skills is of course important in order to do it, but having like the domain knowledge, I think is more important with that, because like ChatGPT can like help you write code, but like it won't, for something like healthcare, I think requires a lot of like knowledge on like career specific terms and stuff. Sure. I was wondering if you think that like AI will like accelerate that process. That was the first part, and then I'll have a follow-up after that.
Just to clarify, when you say like, is it going to speed up people who are new to data science, like recent undergrads, to get a better handle on the domain, or do you mean to say it's going to speed up the domain experts and how they take part of data science?
Yeah, that was the second one.
Okay.
Yeah.
Yeah, I mean, if I could predict what's going to happen with AI, then we wouldn't be here talking. We'd be invested now. But it's hard to say what's going to happen. I think that we're in this weird transitory phase right now where people are discovering that they can kind of click buttons and type things, and in what's called a greenfield project where there's no existing code, maybe like it can just dump all this stuff, which, like if you're trying to build a shop for like a Shopify store for like selling clothes or something like that, like these are really well known problems and their solutions. There's lots of public facing code for like how to build these kind of things, and so it does a good job of kind of like laying that all out. That's good. It does take away a lot of agency away from the designer or the programmer or the person who's trying to be creative, because whether you want it to or not, it does, when you have someone giving you that kind of stuff, it pigeonholes you into not understanding what other possibilities there are unless you've done something like this before. Like, you're like, oh great, it works, like I click on buttons, but you have no consensus about maintainability, testability, like there's all these kind of things that go into the design that you no longer have any control over, and that's really important. And I think for somebody who's not very technical, that kind of stuff can be a good bridge to working with technical people, because you can create very simple stuff where you can create ideas that kind of you can define in plain terms or plain text, and it can create something that's extremely high level for somebody to look at and play with, and that creates like a good dialogue. The problem though becomes when it's like, well, it's suggested that it writes the code this way, so we want it this way. It's like, well, that's not the best way to write that kind of code, or that's not going to be the most maintainable way to create this type of product. Well, it doesn't matter, it's already done, that's how we want to do. So that, on the domain side, that can be problematic. On the engineering side, it can be problematic because you have people who are like a junior engineer who've never written production code now being able to just like
spit it out.
Yeah, but like they still have no idea about maintainability or what makes good quality code in the long run. And it takes years of learning to really understand. I think it'll be faster now if the right person with the right mindset wants to use AI to kind of learn, rather than just like give me everything that I need for my work and it's done. So that's important. Like using AI as a nemesis mode. Like, okay, here's my design. Don't build it. Try and tell me why it's bad. And that's a good way to use AI to try and derive at a better solution, but keeping it along the lines of what you had envisioned. Yeah, I think that I'm kind of like answering multiple questions now.
No,
But-
it's great.
But I think that AI is going to bridge that gap more and more, hopefully, as long as people use it in the right context and the right approaches. I do think it's going to, as far as like data analysis, data analytics, not data science maybe, it's going to probably make it so that more people can take part of those discussions, but there's going to be probably possibly a higher incidence of like really bad errors.
Risks, yeah.
Yeah. So I think whether it saves money or time is to be determined. You see these commercials now on like YouTube and stuff where it's like, oh, that person can't write an app. It's like, oh, I just wrote this app to do this. And I think those things are really great. But the problem is that you can create something really quickly, but then like there's a whole different, there's a big difference between just creating something to say, hey, I can run a report now, look at this, versus like, okay, this is going to become part of a product that our team relies on for information. We're going to maintain it. We're going to make sure it's working. Like it's a whole different set of questions and concerns that have to be regarded now when you're trying to use something to make decision making in the long term course of like a business or whatever domain you're in, versus like, I just built something that can do X, Y, and Z that hasn't been done before. Oh, look, we're done. So that's one area. And also if you have people who are working on like older code bases or legacy code or legacy data science projects even, or data products, it can be very difficult to, so there's lots of like buttons and stuff I'm pressing and things are happening. It can be very difficult to get the AI to reason about why things were done and to create changes in a very step-by-step, meaningful way that allows other engineers to understand why changes have been made and what's happening. And so that can be very difficult. And for non-technical people, you have this like candy store now and everything looks delicious, but it's all kind of bad for you if it's not eaten in the correct amounts. And so I think there's going to be a lot of too muchlessness over the next several years, but I think that regression to the mean, it'll kind of settle down maybe, unless, AGI happens and we're all dead anyways.
Yeah.
But, I think there'll be some, I don't think it's so much of a tooling problem. I think it's clear that like AI can generate code. It's more of like, how do you allow technical and non-technical people to derive at decisions and things that will improve the business's life, the employees' lives, and the end users or the customer's life. How do you get that stuff out there faster, get a lot of the domain that's in the employees that aren't technical, matching with the technical employees to build stuff. Like those are all really ill-defined still and not quite sure how it's going to work yet. But the technology is going so fast that it's there. It's just we don't know yet how maybe to use it in the best way. And so I think a large area in data science is going to be trying to figure out how best to use this stuff to accomplish things rather than just say, we can do it. Because, just because you can do something doesn't mean that you should or it's going to be helpful. Just doing something at the very best adds to the signal to noise ratio. At the very worst, it makes that ratio, much larger.
Yeah.
And so, that's kind of a difficulty. So I don't know if that answers the first part of your question.
No, I think that was great. I think what's interesting is like I think you said AI is kind of like using chat or like anything for code is like a double-edged sword in that I think I'm also running into this problem myself because there are certain like projects that I've been trying to do, or I think like many other undergraduates might be trying to like do something that would have been out of their scope without AI, and like knowing how to prompt it so it's not just spitting out code that you don't understand, while at the same time like learning or knowing, I guess, what should be like what is something that can be given to AI to write or versus something that you should learn yourself. So I was wondering if you have any thoughts on like what do you think is like a good mindset when using ChatGPT or tools, generative AI? Like,
well, I feel like a lot of students are probably not going to like me saying this, but I feel like so there's a difference when let's say let's say like a professional who's using AI to help write code versus like a student. Like for a professional, they're getting paid to produce something based on all the tools, experiences, and abilities that they have. And AI in that sense is a tool, and it might be also a proxy slightly for some ability, certainly for time. And so they can determine whether to use those tools and how to use them, and then they can take on the professional responsibility of saying, okay, well, if this thing messes up, then that's on me, because I didn't read the code, and I didn't, look at everything that it wrote and then talked with it, spoke with the AI, whatever agent that you're using to say like, well, why'd you do this? Or it would be better if you did it this way. That's one experience. The other one is from a student's point of view, you got to think about, well, I'm paying, or someone's paying some amount of money for me to go here for some amount of time. And the goal of education shouldn't be to get X, Y, and Z done, because that's not the point of that's not what you're trying to produce. What you're trying to produce, good grades are a really poor correlate for what you're trying to produce, but I suppose that could be one marker. But the main thing you're trying to produce is an ability to look at what you know and how to go learn more on your own, as well as how to increase your knowledge of some discipline that you're interested in, be it the classics or philosophy, all the way to computer science or math or biology. And so if you rely on AI agents too much to do those things, you're robbing yourself of your ability to go through those processes and cause that neuroplasticity in your brain to start morphing your neural connections to allow you to learn something new. And so if you do that too much, at some point you're going to get to a point where you don't know what you don't know, and it's hard for you to kind of gauge that. And I think kind of using AI to do things, like for my capstone project, I tell students, like, I would rather have a lesser quality project that you've done mostly yourself than one that's really super polished and better, but AI did everything, because you're going to learn a lot more. And then you can always turn around and use AI at the end to kind of polish things up quickly and stuff. But if you just rely on it, you're robbing yourself of this unique opportunity that you have. And so, if I know one thing about life, is that it's very rare to have the chance in life to sit down for several hours a day and just learn. Like this will not be something that you have very much of anymore once you graduate. It goes down the more responsibilities you get in life. And so you should use the fact that you have this much time now to study and learn, and to do that and not rob yourself of that opportunity by using AI just to simply finish something, because finishing it isn't the goal. The goal is to learn while you're trying to finish something. And I know people believe grades are like meaningless in the real world. I mean, if you're going to grad school, grad school, sure, you have to have somewhat good grades, but that's just one part of it. Letters of record much more important, and experience. But but of course the other side of that is that we're entering the world now where AI is going to be a primary thing that people are expected. If not today, it's certainly within 5 years, if not sooner. But certainly within 5 years, everybody will be using AI probably. I would. This is a safe bet, I would assume. And so, as a student, you want to learn how to use AI. Now, the curriculum isn't change. This is a bureaucracy. So nothing changes fast enough compared to how fast OpenAI can put out the next model. And so, or a new tool comes around. And so, as a student, it's very tempting to be able to use these things, offload that time, because then you say, I can do more stuff. I can do more things. I can take even more classes, but you're really learning as much. And so I think your responsibility as a student that you have to be able to take under your own control and not rely on the university or other people is, how do I maintain the balance of learning while also understanding how best to use AI to enhance my learning and to get things done, so that when I go and do interviews or go for work, I can show them that I myself have the skills necessary to do this stuff. I can also use AI tools to enhance those skills. But if you say I wrote some code and then I used AI to generate 20 tests for me, I'm brilliant. All these tests are done, but you don't understand why those tests are being created, why they're important, what is it important to test, why are these tests important, why are tests important maybe in data science, you don't even answer those questions. You're able to just spit out some code and that's done now, but it's a poor proxy for actually sitting down and thinking about what tests I need. And also too, if you're able to write down those things more in a more systematic and to a better degree, your prompts to AI will always be better, and you'll have more control over the process. I don't think it's a bad thing, AI writing code for people, but why would you want to have it take your job and do it for you? I want to be the one in control of what I'm producing, and I want to be super polished and of higher quality, because AI has given me the knowledge of millions of programmers around me, and has some knowledge that I don't have, that's able to enhance what I'm doing, but it's under my direction, rather than just I don't know really what to do. You just tell me. Looks good.
Yeah.
And I think that's really dangerous because, I mean, there's also the social and moral implications of having a workforce that just does that.
Right.
But, I mean, as you as a person, like, you're stripping away your agency and ability to do things yourself. I think it's kind of a sad thing because then why are you even, I mean, I guess you're in college because society has deemed it the appropriate thing to do. But yeah, at that point, like, why are you even in this field? Like, you know, it's sort of kind of sad.
I see.
I guess, I don't know. Maybe it's just a philosophical argument.
Implications. And I definitely see where you're going with, like, as a student, I think your obligation is more to yourself rather than to a company. So it's less about the output and more about like the learning.
Yeah,
learning
like, I mean,
process.
this is your job.
Yeah.
So the best way you do your job is to make sure you're learning, not that you're asking something to do your learning on your behalf. Like, if a student just uses AI, like, at the very worst, or at the very best, you're getting work done for you, and so you can go play whatever people play nowadays. But at the very worst, you're actually paying money to help these companies train and learn their models. Like, you're distributing your learning to other models. Now you're paying them to learn.
Yeah.
And so it's kind of like a weird social contract in that sense.
Like a weird cycle. I totally see. That's really interesting. And okay, I think earlier you talked about like having domain expertise as being really important in this day and age because data science is like less a catch-all and more specialized. I was wondering, like, for students who don't necessarily have a specialization, who know that they want to do data science as a future career, like don't necessarily know which sector, whether that be healthcare or like politics, because it's so interdisciplinary, like what advice you would give them if they should start specializing now, or if you think it's something that maybe they can develop the technical skills first, and then after they go out into the workforce, like play around a little bit, I guess, and see which fields speak to them.
Yeah, it's a good question because it's sort of the existential crisis that I believe students have right now. And so, I mean, it's the best advice to give would be like, well, you know, go and get some internships, try different domains, and, you know, play around, have fun, meet people. But I mean, in today's world, you just can't go get an internship. It's very hard. So it's like, you know, crappy advice. So I would say, as a student, what resources do you have? Well, you have classes, and classes are kind of a shallow proxy for domain knowledge in the sense that, like, if I went to go take a epidemiology class, I would definitely learn something about the healthcare system. If I went to go take a econometrics class, I would definitely learn something about working in econ. You know, if I was going to take a business management or an accounting class, I learned something about working in, you know, finance. And so you can kind of take those type of classes, or if they won't let you for some reason, you hear also stories of people not letting people in classes for some reason. But yeah, you can go get a textbook, you can go take a Coursera class, or I mean, you can definitely learn on your own. And like, are you willing to sit there for hours on end reading about this domain, understanding it? Or are you like, oh, this sucks, when is this over? And then if so, like, maybe you don't like working in that domain. You know, if like you read about healthcare stuff, you're like, this is really exciting, these are problems I want to work on. And that's a really strong signal as to what you might want to do. I do think as data science, it's very hard to not have some sort of specialty. Like, there's no really such thing as a generalist data scientist as much. Maybe there's like the AI agents now. But yeah, you want to have some sort of, it's much easier to go get a job in like healthcare analytics if you have a bunch of projects and classes and like an internship, and you can craft this narrative around like, I am a healthcare analytics data science student who's on these things, and like I'm going towards working in this field, versus like, well, I've done a project on this, I did a project on that, I don't really know what I want to do, but you've got an internship and it's paying, so let me, exactly. And of course, like as a student, you know, like it's hard to have that, and you know, people change their mind all the time, and that's fine. But it is much easier if you're able to craft such a narrative. And so early on, taking as many variety of classes as possible, talking to a bunch of people, looking at lectures online of like data scientists who are talking about projects that they've done, like you can have a pretty good sense for what you like and what you don't like. You know, and if you don't, then I mean, I don't know.
Don't pick a different,
like
different specialization.
Yeah, like how do you make any choice in life? But like at some point you have to have some domain that you work in, and the only way to really go forward in that domain is to really learn more about it. And then people who are like a machine learning engineer, whatever that means today, they're still working on machine learning algorithms in some domain. The types of errors the types of things that you're trying to optimize the algorithm to predict, it definitely does force you to learn more about that domain.
Right.
Because if not, you're just sort of stuck with generalizations, and in a lot of specific fields, certain things help the project or the model that you're working on to perform better, and a lot of that insight comes from the domain.
Right.
And so it kind of behooves you as a student to sort of try and figure out at least what areas you might like. Maybe it's like, oh, I love sports analytics. Well, go read fan graphs or go to those statistics chat forums, and like we have real statisticians who are interested in baseball and sports looking at data and talking like that. If you love that, then you should be all in on that. And then that can help you to get to that internship or into that field better than just meandering around doing a bunch of random stuff. For a while, that's okay, but at a certain point, you have to
Decide.
Yeah, and it's okay if your first job you're filling things out and you're like, well, it's not for me. You can start to move over. Like, that's fine. Nothing wrong with that. I mean, you got to think about it. If any number of the things in life today that could kill us don't kill us.
Yes.
Um,
There are many.
There are many, and they keep evolving and growing.
Yes.
You might have like from 20 to 65, will probably be retiring at 80 by the time we're up there. It's like 60 years of work. Like, you could have 3 careers. You have 3 very different careers. You could go be a circus for 10 years. You could then be a data scientist for 20 years. You could go work in the firefighter. Yeah, I mean, there's so many things you could do. And so it's more about building generalizable skills that translate across many different disciplines, and then picking something and kind of going with it, but always making sure that you are learning stuff that's transferable. Transferable skills are like, how do you ask the right questions? How do you solve problems? How do you talk to people? Being able to do public speaking, like that. All these kind of transferable general skills are really important to build constantly while still specializing. You can't just be I'm good at data science, that's it. I mean, everybody's good at data science nowadays.
Yeah,
like my accountant's been good at data science for the last 10 years. So it's a shallow argument to make for why you should get a job. You have to have some sort of narrative, some sort of specialization, something that you can craft the story and convince people that you want to be there and that you deserve their time and their learning. Your first job really should be picking a team or a company that you're going to learn a lot, and you're going to not be. That's why it's like you always have like, I'm going to join a startup or do something. It's like, yeah, you're going to join a startup as like the chief technical officer trying to scale a large company. I've never done anything like this before. Yeah, it's kind of hard to do those things and do them well and not. So you really want to be in the learning phase for at least like the first 2 years of your career. It's really important because once you get to a certain age too, you're kind of expected to perform and like not make certain mistakes or like to be able to do things. And like if a person with a master's degree and a bachelor's degree apply for the same job, just in your own head, the person who's interviewing is probably thinking like, well, if the master's person performs at the same level as the bachelor's person, I'm going to take the bachelor's degree person because like, what have they been doing? Like, why are they not at a higher level? Just intrinsically, like they should be having more experience, even if they're applying for the same job. As you accrue more experience, you need to see it. You need to be able to look at it from other people's point of view. Like, how does this person view me? Like empathy and be able to walk in other people's shoes is really important to building a career.
I see. I think the advice that you gave about specializing in terms of like finding an internship is really interesting, because I've gotten that advice too, that like when recruiters are like looking at resumes, it's not necessarily like the things that they're looking for are like the ones suited for that specific task, whether that be like if it's like healthcare, maybe not like the specific language. I don't know if this is like this is advice I heard from a while ago, but like having it tailored to that specific position. So I guess in that sense, I was wondering like because now I think the job market is definitely a lot more competitive than it was like 10 years ago. Like what advice you would also give to undergraduates who are looking for jobs at this stage, like which experiences you think are more important than others, and like if they should, back to like the specialization part, like if they should, when they seek out jobs, rather than applying to like a larger variety, like maybe find specific skills that are specialized for those positions and apply an error.
Yeah, I mean, getting experience is very difficult. I always tell people, like, a really good way to get experience is to start working on open source projects. I mean, there's tons of open issues with NumPy and Pandas, I'm sure, and like all the libraries that you use for, especially if it's like a specific, let's say you're interested in geospatial analytics, there's tons of geospatial libraries that are used in industry that are tons of open issues, and And it's very hard to do this, but you can actually, if you're really willing to learn and put the time in and understand, you can make actual contributions to open source production quality code maintained by real senior and mid-level engineers, and you can kind of work with them, and it shows a lot of like being able to go put yourself out there, learn a library, and write code to a high quality and work with real engineers. And I mean, I always tell people to do this, but nobody or very few people actually do it. Yeah, because it's very hard. It's not easy, but it's a really great way of communicating to another engineer or to a person who's interviewing you that you have a lot of the skills that they're going to want to see on the first day of your job, right? Like getting involved, trying to figure out how to do things. Those are like if you're going to go interview and like taking the empathy thing back into account, if I'm being interviewed by another colleague as engineer, their entire train of thought is most likely, oh God, I'm going to work with this person. I hope they don't bother me and waste my time. And so what bothers engineers and wastes their time is people who ask them tons of questions. Oh, how do I set up my environment? How do I build this? How do I set up Docker? Oh, how do I, like all these kind of minutia things that like if you just read the documentation or you just followed instructions, you should go to do yourself. And so if you can contribute to an open source project, you can download the code base, you can run the test suite, you can do all these things, you can write a proper PR, and that shows them like, I'm much more impressed by that than somebody who got a 4.0 in all their CS classes, or DS classes versus somebody who got like a 3.0, right? Because that's kind of you can't apply that one-to-one onto the job, but like an internship is much more application of one-to-one than stuff. The open source thing is nobody has to accept you. You can just, they're open source. You can choose to start working with people, and people want all sorts of help in open source projects. So it's a good way to start to get some of that experience. So that's like one thing. Really, it's putting yourself out there and meeting people. Like people like to go to LinkedIn or Indeed and do the quick apply crap. Like anything that's quick apply or just dumping your resume onto people is such a low signal noise ratio that as to be useless. Yeah. Like if I'm a recruiter, going back to this empathy question, I'm putting myself into the mind space of a recruiter. I've got 1,000 applications from Indeed and LinkedIn that are quick apply, and I've got like 10 resumes that people who work there have given me. I'm not going to look at the 1,000. That's like
the 10 resumes.
Exactly.
Right.
And so meeting people, and it used to be a little bit easier, but now it's much more difficult. Like I remember I was looking for jobs when I was younger and stuff. I would just try and find out through LinkedIn or like who works at a company, and then calling the switchboard and say, hey, I was supposed to meet this XYZ person. Can you just connect me to their office, and then just connect you, and then you leave a message or they answer the phone, just like, hey, you got a quick, like 2-sentence thing, like I can help you guys solve some of your problems. Like that's really hard to do nowadays.
No switchboards.
Yeah, things are much. Things are like, something like connecting you to, I'm not that old, but like there's a lot of people are getting calls anymore and stuff. And so it's all through email now, or Slack. And that's not an option that's available to people very easily if you work there. And so having the ability to meet lots of people and have them kind of like put your resume in front of people will not be a guarantee, of course, but all it does is improve the probability.
Drastically.
Yeah.
I'd imagine.
And so compared to like quick apply on LinkedIn, and like really looking at the job, crafting your resume for that job, making sure that somebody's going to recommend you, like you're probably still going to get rejected in today's world, unfortunately. But it's an important thing to be used to putting the time in to make something that somebody is going to want to see, because if not, why would they put the time into making sure that you get a phone screen or an interview? I mean, there's a little bit of like a social contract there. It's easier said than done. It's very hard, especially if you're like an international student, like trying to find something that will support you, like a company. It's not easy at all. And so these are like really big sweeping generalizations, and it's like, yeah, that's great advice, Kyle, but is it really going to work? And probably in a lot of cases it won't, but it will definitely be better than just applying like with Quick Apply through LinkedIn. You've got to go, and if you can, go to conferences and meet people, talk to people. This is a little bit easier before COVID. Local companies like Qualcomm are the ones that have like little social events you can sign up for, and you can go there and listen to a talk from an engineer, and then mingle and meet people. That was very good. A lot of that kind of went downhill though. Yeah. But there's other like meetup groups and stuff. Like you really want to just get involved in the community. And I mean, UCSD is a great community, but it's not a professional community like, people who go to a conference looking for a job, like I don't know, Ruby conference or any of these kind of conferences. And those are expensive to go to, of course. If you can go, it's great, and you can probably make good connections there if you're a halfway decent person. But you have to try and find people and grow your community, because if not, all you're doing is relying on probability.
Right.
And relying on probability in 2026.
In today's world.
Yeah, it's very hard.
Very tough. Very tough. I see. What are your thoughts on personal projects? Because I've heard conflicting things about this. I've heard people say that like they're a great way to show recruiters that you've actually dealt with the student besides just like doing stuff in class. But I've also heard that like because of AI and stuff, it's like so easy to work on these projects nowadays without actually having those skills. So what's your opinion on that?
I mean, personal projects are great as long as it's like something you're really fascinated with, interested in. Like doing a project just to do a project to get under your belt is not a very good idea. It's a recipe for disaster. Mm-hmm. Really, you want to build something that's useful and that you can put it out there. So like when I was getting into, I was trying to get more into Ruby on Rails, and so like a personal project that I did was during COVID, writing in a little Twitter bot with like a back-end Ruby on Rails application that would go and scrape CVS and other pharmaceutical providers, as well as use some APIs, trying to figure out whether there's open appointments in San Diego. And then, like there'd be a quick link and a tweet every, 10 minutes, open appointments. You just click a link, and it would embed you as deep into the hierarchical navigation that it would allow me to where you could just sign up for the appointment very easily. Yeah. And so like, did I write the best Ruby on Rails code? No, it's horrible. It was god awful. It was terrible. It was all terrible, but it worked. And it was, it was featured KBBS, and like ABC 10 News did like a thing on it. And so like, it wasn't a project. It was a project to learn how to code Ruby on Rails, do that stuff better. And it was more though something that I really cared about and thought would help. And, it just happened to kind of snowball, and people really liked it, or some people liked it at least. And, it wasn't a great technical showcase. What's more important is that it showed somebody that, hey, I can take a problem I see today and then craft a technical solution around it. I mean, I'm sure with AI, the code would have been, would have taken me a quarter of the time to do. Yes. But, like it was me trying to like solve something while learning something. And I think that is a much stronger signal for like a personal project rather than just like, oh, here's some Kaggle data set. Let me do something mildly interesting with it and build a visual. And like, yeah, it's just like a project for the sake of doing a project. It makes not a good project. Right. A project that helps you personally solve a problem, or even better, helps other people solve problems. That's why like Claudebot or whatever was it called now, like that's why I think took off, because it was useful to people. Right. And people are like, well, I was just some like guy that wrote some code and did whatever. I mean, whatever the backstory is behind it, it's somebody who identified a problem and worked towards driving at a solution that they cared about, and it was, it picked up traction because of that. Did he build it as well as he could have? Probably not. Did he build it as well as if he had like a team with him? Probably not. I don't know. But it was a personal project that he cared deeply about and found useful. So that's the first thing. A project just can't be a project if you're doing one. There has to be some utility to it, because you're not going to interview, like I'm not going to like turn my computer and be like, hey, look at my crappy Ruby code. It's going to be explaining to them like the purpose and the drive and the theatrics behind showing people what you did is way more important. And so if you're going to do a personal project, it's got to be done with intention and for a reason. It's okay to iterate and play or build a project for the sake of building a project, but that shouldn't be your like showcase. Right. Think of it as like if you're an artist and they have to do a portfolio to get into school, like obviously the portfolio has to show a range of skills and it has to be like really polished, finished pieces. But like you're not going to just like take some some drawings that you did, like, oh, there's my portfolio, I did it. You're going to practice a lot. You're going to throw a bunch of, those drawings away because they're crap. They're you trying to explore the problem space, learn, and then finally, when you have some of that technical skill, and then you have a problem or like a subject that you really want to draw or a problem you really want to solve, then you can go ahead and do it. And is the drawing still going to be technically crap? Yeah, probably. I mean, compared to a professional artist, sure. Yeah. But it at least shows that you're beginning to try and make your tooling and your tool, get better at your craft, and you're also kind of care about this now, and it's got some sort of interest in it. And if you don't do that, it's very hard to, like, if you yourself don't care about your project deeply, why the hell would anybody else care about it? If everyone else cares about it, then they're just like, great, you did something. Okay, everybody else has done a project. Like, what makes you stand out? And so that's a really important part to have, because if you don't have it, then you kind of, it's like a regression to the mean. You're just sort of get lost in the sea of average projects.
Right. That's really interesting. I don't think I've actually heard that advice, but I definitely see like that's really eye-opening, especially the utility part to think about. I guess I think we have like around 10 minutes left, so I'll just end with like 2 more questions that I have. I think one of them was whether, so like it seems like, in this day and age, like just simply graduating with a degree is not enough. I was wondering like if you think the current curriculum at UCSD, well, I guess this is like more to do with AI as well, but if you think that it is suitable for a future with AI, and if yes, why? And if not, what do you think we can change about the curriculum, or what can we do about that?
Yeah, that's a dangerous question to
ask a professor.
Yeah, I will say that I think this is a very multifaceted kind of answer, because it involves many moving parts. Universities move at a much slower pace. So, for example, like I redesigned the Cogs 8 class, and I want to change the title of the course in the catalog, and because that class is used as a prereq for other majors and stuff, it was like a year and a half to get it changed, because for us a degree. So in a bureaucratic setting, these things move very slow. So that's the first thing to consider. The second thing to consider is that what is data science? It's very ill-defined still, I think, in many ways, and a lot of people have a lot of different opinions about it. That's true. And just designing a course material is very time-consuming and difficult. Like I redid, at least for my version of DSC 100, built it from scratch, and that was like a couple months worth of nights and weekends hammering away at it to make sure it was good. My old friend Beneath and I, who was my TA at the time, built a lot of those auto graders and stuff out, SQL auto graders, relational auto graders, and it was very difficult. So making high quality instruction and multimodal instruction to be used for students who don't want to go to class and students who do want to go to class, and all those other things, is very, very difficult, especially if you really care about it. It's very, very hard. And so with that in mind, I think that the world of technology, data science, AI, whatever this big umbrella term is, it's moving at an extremely fast pace. And because it's hard to predict where it's going to be, it's really hard for a university to make the argument of we've got to create class X, Y, and Z to fulfill today's demands, because by the time it's done being created, there's no guarantee that
will be a demand.
Yeah, tomorrow that it will be the right thing to do. So that's very difficult. I do think, though, that the fundamentals of data science are not so difficult to ascertain and understand. I've always been of the mind that I think it's really important early on to learn SQL. I think learning SQL should be the first thing that students do, because that's almost the first priority in any internship. And I think there's a reason why students can't learn SQL on their own before DSC 10 or whatnot. I think Cogs 9, like intro data science, a lot of students take like in the senior year as an afterthought. But I think with only having DSC 10 and not Cogs 9, you lose a lot of the idea of why we're doing these things and kind of like the broader field of data science. So I think that's important to take early on. For AI stuff, I don't know how the university would create classes around using AI to do stuff. I'm sure there's a roadmap there, perhaps something like where you have to, I've had thoughts in Cogs 9 before, to have students try and change or take an AI that's like really hamstrung and not very high quality, like a really, really old model or something that's like a very small model, and you have to have a conversation with it where you're trying to help it learn something that you know or you're trying to learn, and then you feed that chat to a higher level LLM, and it grades you on your ability to teach other, like that kind of stuff, like introducing feedback loops and very tight feedback loops. I think is very important in education. And so I feel like that is good to do. But yeah, I think the curriculum today, by definition of just how universities work, is not doing the best at integrating AI or teaching students how to use it, and probably because it's not well known how to exactly use it. And so I don't think that the HSI or the university is sitting on our hands not doing this, but I think it's just kind of hard to figure out what's the best way to let students know what is going to come down the pipeline and be built, while also making sure that we're not going to keep going back on our word and changing things. And so that's a very hard rope to walk across with two big chasms on both sides.
Yes.
One the administrations and one the students.
Yeah.
So that is hard. I think as students though, this is where I think this has always been the case, but I think today it's probably even more true, is that you always should not depend on somebody for your education. Like you're paying money and you should put your belief and hopes in the education system and the professors and
What you're learning.
yeah. But you also have to sit down and be mindful of what is it that I'm learning, what do I think is out there, like what can I do to make sure that I'm enhancing my learning and positioning myself. Data science, I used to think, and sometimes I still do, that data science is an undergraduate degree is not a very good idea, because you're trying to learn a bunch of different skills at oftentimes not the same level. Think of math skills, the CS skills, like there's always different skills you're trying to learn, and they're at a certain level, but they're not at the level of like somebody who's just doing math or CS.
It's everything. It's
yeah.
very, yeah.
I'll take that challenge on to anybody. Like that's absolutely true if you look at the classes and curriculum and just like talking to students and what they know. But I think that as a graduate degree, it's really great because you have some deep experience. You can shallow up other areas and then kind of learn how to apply this onto projects. Because data science is very much applied. It's not so much taking theoretical math or something like that. Like you're trying to solve real world problems, and you're, for the most part, while the professors here do research, and so is that data science or is that just research? I don't know. Again, how do you find data science? But for most people who are going to get jobs, like 96% of data science students are probably going to go into the industry and get a job. And so to me, that means that it's the application of data science onto
In the field.
real projects. And a lot of undergraduates are just not like, you might get a job called data science or something, but you're not doing data science, you're doing analytics, or like to do data science really means you have to have a good idea of a business, the domain in which it operates, or whatever domain you're in, and how to solve problems and bring people together. And that takes a lot of experience, a lot of years of experience, leading projects, doing things. It's very hard just to like show up and say, okay, we're gonna do data science projects and change everything now.
Yes.
And so from a graduate point of view, that's a lot more of the type of skills that they're trying to develop. And from an undergraduate point of view, I think sometimes people graduate and they're just sort of like mediocre in all these areas. And now they're trying to compete with CS students for CS jobs and trying to compete with, and so it makes it very difficult. So I think as a student, making sure that you're looking at your education in that view, that line, and understanding how AI is influencing the world and businesses today and how they're using it, and to try and incorporate it in an educative way, not in a, I need to get my stuff done type of way, so that you can talk about how to successfully use AI to enhance a project that you're working on and care about, or how to enhance things that you're working on, or that you understand how to include AI in your tooling. Like some people, I'm just using, what is it now, Claude Code or 8 Codex from OpenAI, or what's the VS Code alternative? That's all AI. There's always different ways of like using AI to do technical projects, and there's no right or wrong way about it now, but you've got to formulate an opinion, and you have to kind of like look at and observe like a scientist, kind of using all these tools in different use cases, and understand how they work and why you might want to use one workflow or do something better. You just can't like, oh, it's just what I do because it's what I do. Like, you treat it like a tool. Like if I'm going to use a programming language to solve a problem, I'm going to evaluate my languages that I know and what their pros and cons are, or I'm going to look at the technology that I can use to solve a problem. And AI becomes just another tool and a technology in your tool belt. And you have to make sure that you're using the right tool and you're using it the correct way. And I think that is hard for a university system to teach people how to do. And so it kind of falls on you to do it a little bit. And I think that's a fair way, without poking too much fun at the university and its choice in classes and stuff. I think everything can always be optimized. Hindsight's 20/20.
Yeah, of course.
And HSI was one of the first undergraduate programs to do this, and so a lot has changed, and it's just very hard to change stuff. But I think things are always moving the right direction. I hope.
Hopefully.
But but it's very difficult. Like there's a lot of even things about classes that I teach right now that I would change. Like I would change 48 quite a bit. I would change DSC 100 even quite a bit if I was to sit down and redo it now based on how people are using tools in industry and how people are solving problems. But there'd still be that grounding in the fundamentals, which you can carry with you to any technical job, or to a lot of jobs. And those are that I think is the responsibility of the university to make sure all students have.
Right. So it's kind of something. It's a difficult problem,
Mm-hmm.
and it requires, I think, a lot of thinking. And I guess what you're also saying is like students can do something about it, and they should also like be mindful about it in the process. Okay. I guess I'll end with a fun, maybe little personal question. But I was wondering. If you were to like look back at yourself, if you were in undergrad, like years before today, what piece of advice would you give to yourself? And that can be in general, or it can also be in terms of like career-wise.
Okay. I first thought you were gonna be like, don't forget to like, follow, and subscribe.
Yeah, I'll say that at the end.
But I mean, so like, what kind of advice I give myself? I think I've talked ad nauseum about like advice towards doing projects and that kind of stuff, and I've talked about that type of stuff a lot in other contexts as well. I think as an undergrad, the thing that you can probably do and the most of is try and put yourself in situations that make you feel as nervous and anxious as possible. Because life is not easy, and there's gonna be lots of like, imagine again, like be empathetic with yourself in 2 years. You get your first job, you walk through the doors, and like everyone kind of turns and looks at you, and you're like, uh-oh. Right, like that, like think how you're gonna feel. Why would you not want to try and recreate that feeling as much as possible in a safer environment here where failure doesn't matter as much, and you can get good at like, maybe you're like, dancing is the worst thing that could ever happen to me. Take a dance class, try and force yourself to overcome those feelings of maybe they're inadequacy, or maybe they're just like, everyone's watching me, or I suck at this, like, because that's how you're gonna feel a lot of times in life, going through a lot of different things. And so you should try and recreate those types of scenarios for yourself here while you're learning, and in an environment where you can do it, so that when you go into these higher stake environments, your first interview, your first job, like you already know how to deal with those feelings or emotions, or you're able to go through that much easier because you already have gone through it before. Take classes with, take a ceramics class, or do stuff that you would never think to do, because one, you're not going to have very many opportunities to do this later in life as you will now. You never know what you're going to wind up liking, and it helps you be a much more well-rounded person, have lots of hobbies. You would be surprised at how many interviews transform into just talking about hobbies with people, and they're like, oh yeah, we'll talk about the technical stuff for a little bit, but you play, exactly. So there's lots of stuff. You want to be a well-rounded person, and I think those things are really important, because there's a large number of technical classes, math classes you can take, and really none of it matters what you take or don't take. What matters is how well-rounded of a person you are and how well you work with other people, and being in situations where you know how to like calm yourself down and be okay being in certain situations that learn how to do public speaking. It's a big one, especially with data science. You go to talk to people, and so like being in those environments and overcoming those things winds up being very helpful for you as an individual growing into a career and trying to figure out what you want out of life. It's not just going to be taking classes and technical stuff, and that's like, creating a career is a very large endeavor with many facets to it, and who you are as a person, how you work with others is a really important piece to that. Be evaluating yourself rigorously. Do you suck at meeting deadlines? You tell people that I'm gonna do this and that, and you just don't do it. Like, be honest with yourself. If you're the kind of person that does that, find a way to stop doing that. Like, be very critical of yourself and try and improve, because those sort of things come out very easily in the workforce, and you'll be known as a person who does X, Y, and Z, and then it just makes things harder for you. So, those are all good things to make sure you are able to shape yourself as a person to be the professional that you want to be. And in college, you have the unique ability to do a lot of that molding and to put yourself in a lot of interesting situations that will help you be a much better professional or person 5-10 years down the road. So I think those are good experiences to have. much more important than taking an extra math class that you'll probably never use any of that stuff.
Right. Thank you. That was really insightful. That's something that I will for sure take myself. Okay, well, that was the last question. Thank you so much.
Yeah.
Make sure to like, comment, and subscribe.
Like,
I think
follow,
this
and
is-
subscribe.
Yeah, like, follow, and
But also
subscribe.
comment too.
And comment as well. Yeah, perfect. Thank
Yeah.
you so much for your time.
No problem. Thanks so much. Happy to
Okay.
be here.